Hi students, in this chapter we're going to learn about the states of matter. We all know that water becomes ice when you cool it below a certain temperature. Similarly, the water we see in waterfalls or the water we drink, it's in the liquid state, isn't it? Similarly, when we boil water, steam comes out. Steam is a gas, isn't it? That's what we're going to study about in this chapter. The states of matter: solids, liquids and gases. Ice, water and steam. So let's study in detail exactly what are the properties of solids, what are the properties of liquids, what are the properties of gases, and then let's try to understand all these at the level of particles and molecules. Let's proceed. The states of matter. As we already know, the three states of matter are solids, liquids and gases. Let's discuss some properties of solids. These properties are common for all solids. Consider this book, this pen, these two logs here. All of them are solids. If you look around, you'll see that the computer you're using, the table, the books around you, the glasses, all of them are solids. One amazing property of solids is that they have a fixed shape and volume. Look at this yellow book here. Its shape is fixed and its volume is fixed too. If you move your hand, along the edge of this book, you'll see that its shape does not change. It's fixed. Similarly, the volume is constant. Solids have another important property. They can't be compressed. So if you try to press this book down, press it hard, you'll still see that there's hardly any compression in the book. The book does not become, thinner. It still stays the same book with the same fixed shape. So these are two important properties of solids. Solids have a fixed shape and volume and they can't be compressed. Then of course solids have another property. Solids in general have a very high density and they are very heavy. If you weigh, an average book, its weight might be something around 1 kg. This book, for example, which is so thick, weighs 1.5 kilograms, as you can see from the mass balance. The point is that solids in general are very heavy and they have very high density. Density refers to the mass per unit volume of a substance. So, how much does 1 meter cube of a substance weigh, or how much does 1 liter of a substance weigh? That's what density means. We already know, for example, that if you take 1 liter or 1000 centimeter cube of iron, the iron block will be very, very heavy. On the other hand, a liter of water is so light. So you can say that solids have high density. Another fascinating property of solids, which you're already familiar with, is that they do not fill up a container completely. If you take a large container like this blue container here, and if you drop a book, which is a solid, into the container, the solid will still occupy the same volume that it was occupying earlier. It will not expand to fill up the entire container. Now this might seem obvious, but it is also an important property of solids. There's empty space all around this book because the book does not expand to fill up the container. It retains its volume. So these were the important properties of solids. The first thing was that solids have a fixed shape and they have a fixed volume. The second thing was that solids in general cannot be compressed. The third thing was that solids have very, very high densities. And of course, then we just saw that they do not fill up a container completely. So these are the important properties of solids. Why exactly do solids have these properties? We'll study all that later in this chapter. For now, let's solve a small problem related to these properties of solids. When we pour sugar in a container, the mass of sugar takes the shape of the container. Then how can the shape of sugar, a solid, be constant? Now that's an interesting question, isn't it? After all, when you pour sugar in a container, the sugar takes up the shape of the container. But we just discussed that the shape of a solid is constant. Then how can sugar be a solid? Well, the answer is quite easy. Yes, a mass of sugar does change its shape in different containers. The container on the left, the container in the middle, and the container on the right, all of them have different shapes, and you can see that sugar fits in all these containers and assumes different shapes. But the important point is that the sugar crystals, the small crystals of sugar here, they do not change their shape. They are still cubical or cuboidal. It is the net mass of sugar that is changing its shape, but the sugar crystal, that is not changing its shape. These crystals here, they retain their shape, isn't it? The shape of each sugar crystal is the same no matter what container you're using. That is why we can say that sugar in general is not changing its shape. But since sugar crystals are so small, the combination of so many sugar crystals, that is changing its shape in different containers. So that is the answer of this question. Understood? Solids have a constant shape. Here's another problem. What about a sponge? We can compress a sponge, right? But solids cannot be compressed. Does that mean that a sponge is not a solid? We know that it is a solid. Well, what do you think is the answer? The answer is that a sponge has a lot of air trapped in it. As you can see, there are so many air spaces here. When we compress the sponge like this, the air escapes out of the sponge, and that is why the sponge gets compressed. Note that the actual substance, which forms the sponge, that is not getting compressed. The solid part of the sponge is not getting compressed. Air is going out of the sponge, and that is why we are able to compress the mass of sponge. Understood? So, when the sponge is not compressed, when it is in its expanded form, in that case, air is filled up inside the sponge. When we compress the sponge, the air goes out, and that is when the sponge, occupies its original shape without the air. And that is the answer for this question. Understood? So those were the properties of solids. What about the properties of liquids? Let's move on. There are many common liquids that we see in our daily life. Milk is a liquid. Kerosene oil is a liquid. Even the Coke we drink is a liquid. As you can see, liquids are all around us. One important property of liquids is that they have a fixed volume, but they don't have a fixed shape. Now that is obvious too. You can take some water in a glass, and this is how it will be. You can take the same water in a glass of higher width and lesser height, and this is how it will be. What you can see here is that the shape of the water in both cases is different. In the glass, the water forms a perfect cylinder. But in this weird glass, which is, of a greater width and smaller height, the water forms a special kind of shape, which is not a perfect cylinder. So the shape of water basically depends on the container in which the water is poured. The shape of all liquids in general depends on the container in which they are poured. However, the volume of the liquid does not change. It's constant. For example, the volume of the water in the glass on the left and the volume of water in the glass on the right, both are the same. If you take a measuring cylinder and if you pour water from both these glasses into the measuring cylinder, you will see that the level of water is exactly the same. This is because the same volume of water can be poured into different glasses and it will assume different shapes, but the volume of water won't change. Understood? There you go. The second property of liquids is that there is very less compression in liquids. Now, solids were virtually incompressible. You cannot compress them at all. Liquids can be compressed, but very, very slightly. Not much. So this is the second property of liquids. The third property of liquids is that the density of liquids is generally less than that of solids. So you could say that the same volume of a liquid will weigh much lesser than an equal volume of a solid. Understood? So for example, if you take this water glass, the water will weigh a certain amount. But when you replace this water glass with the exactly same volume of iron, look at this arrow here. This arrow is clearly showing that the weight of the iron has increased by a great amount. So when you have water, the water has a certain weight. But when you replace the water by an exactly equal volume of iron, the weight increases considerably. In fact, the mass per unit volume or the density of water is 1000 kilogram per meter cube. What this means is that approximately 1 meter cube of water weighs 1000 kilograms. However, the density of silver is 10,600 kilograms per meter cube. This means that the same 1 meter cube of silver weighs 10,600 kilograms. Can you believe that? 1 meter cube of water weighs 1000 kilograms, but 1 meter cube of silver weighs 10,600 kilograms. So as you can see, the density of liquids is less than that of solids. Another fascinating fact related to liquids is they do not fill the container completely. If you consider this brown container here, which initially has vacuum in it, that is, it does not have any gas in it. Now when you add some water to this container, you will see that the water fills up in the container only up to a certain height. It does not go up and fill the container completely. There is a lot of empty space. As you can see, this white area here represents empty space. So liquids don't fill up containers completely. Another fascinating property of liquids is that liquids flow easily. So for example, if you take this ramp and if you make water fall on this ramp, the water will flow like this. As you can see, the water keeps on flowing continuously. Flowing occurs when one part of the liquid slips over another part of the liquid, and that's why that upper part of the liquid moves on. That's when flowing occurs. It does not happen in solids. So liquids flow easily. So these were the properties of liquids. As you can see, the first property was they have a fixed volume but they do not have a fixed shape. Then we said that liquids are hardly compressible. Then we said that liquids have lesser densities compared to solids. We also said that liquids do not fill up the container completely. They fill up any container only up till a certain height. And again, the last property of liquids is that they can flow easily. Understood? Why do liquids have these properties? Again, we'll discuss that in detail later in this chapter. Now let's turn to gases. What are the properties of gases? Well, unlike solids, which have a fixed shape and fixed volume, and unlike liquids, which don't have a fixed shape but which have a fixed volume, gases don't have either a fixed shape nor a fixed volume. If you take a container like this, and if you add chlorine gas to this container, the chlorine gas will immediately spread and fill up the entire container. So gases immediately take up the shape of the container in which they are there, and they occupy the entire space present in the container. So they don't have any fixed volume, they don't have any fixed shape. You can take 1 meter cube of air which is present in a box, and if you transfer that air to a container which has a volume of 10 meter cube, then the volume of air will become 10 meter cube. If you take the same air and put it in a container which has a volume of say 100 centimeter cube, in that case the volume of the same air will become 100 centimeter cube. So gases don't have any fixed shape and any fixed volume. They take up the volume of the container, they take up the shape of the container. Another property of gases is that gases can be compressed easily, unlike liquids and solids. Solids, as you know, they can hardly be compressed. Liquids, same case. Gases can be easily compressed. Let's take a gas, in this box here. This is chlorine gas, which is green in color. Now, as we move this piston downwards, chlorine gas gets compressed. As you can see, the chlorine gas now only, occupies this volume here, the bottom part of this cylinder. Again, we can move this piston up and the chlorine gas will fill up the entire container. We can again compress the chlorine gas and it will again take up only a very small volume. So gases can be compressed. Unlike liquids and solids, gases have extremely low densities. This means that even a very large volume of a gas will in general weigh very, very less. If you want to compare the densities of gases and liquids, you can compare the density of air and water. The density of air is 1 by 800 times that of water. Did you know that? This means that at 0 degrees Celsius and 1 atmosphere pressure, the conditions that all of us live in, air basically is 800 times lighter than water. This means that if you take a mass balance, then you'll see that 1 liter of air weighs as much as 1.3 milliliters of water at standard temperature and pressure. Understood? Clearly, the densities of gases are much lesser than the densities of liquids, isn't it? Another important property of gases is that they flow easily. As I said earlier, flowing occurs when the particles of a substance slip over other particles of the substance and move forward. Since that happens in liquids, it happens even more easily in gases. So those were the properties of solids, liquids and gases. Do you remember them? I'll just repeat the properties of gases for you. Gases do not have a fixed shape and fixed volume. Gases can be compressed easily. Gases have very low densities and gases can flow easily. In fact, let's take a look at this table which represents the major properties of solids, liquids and gases. You can look at the table and compare the properties of solids, liquids and gases. Here's the table listing the properties of solids, liquids and gases. As you can see, solids have a fixed shape and volume, liquids have a fixed volume but no fixed shape. They take up the shape of the container. And gases, they have no fixed shape and no fixed volume. They are free to move anywhere they want. Solids cannot be compressed, liquids cannot be compressed, but gases can be compressed easily. Solids have very high densities, liquids have medium to high densities, while gases, as you just saw, they have very low densities. Similarly, solids do not fill up the container completely. Liquids also do not fill up the container completely, but if you put a gas in any container, the gas will fill up the container completely. So there will be no empty space in the container. Solids cannot flow, but liquids and gases can flow. So these are the properties of solids, liquids and gases. Now there's one doubt, isn't it? Why do solids, liquids and gases have these very properties? Like, what is it about solids that they do not flow? Why do solids not fill up the container completely? Similarly, why do solids have high densities? So what is the reason for solids, liquids and gases to have these properties? Let's study about that now. The reasons for these properties. The reasons for these properties of solids, liquids and gases lie in the structure of solids, liquids and gases. Solids consist of particles which are very near each other. So these particles attract each other a lot and they are not really free to move away from their positions. The position of these particles is fixed. So the particles of a solid very slowly vibrate about their mean positions, but they don't move farther away from each other. There are strong forces of attraction between the solid particles, and so the particles are held fixed in certain positions. In the case of liquids, the particles of a liquid are free to move to a certain extent. There are forces of attraction between the particles of a liquid, but these forces of attraction are not so strong, to fix the position of the particles of the liquid. The particles of a liquid are able to move for quite some distance, but then that distance is fixed. They can move from here to there, but not anywhere. That is the reason a liquid has fixed volume, but it does not have a fixed shape, isn't it? So as you can see, the particles of a liquid move faster than the particles of a solid. They can move away from their positions, but still the force of attraction between these particles is quite strong. Gases, however, are on the other extreme. The particles of gases move very fast. They are absolutely free to move, and there are hardly any forces of attraction between the particles of a gas. As you can see, the particles can move anywhere and everywhere. If you place a gas in a container, the particles will move and fill up the container. So as you can see, on one end, the particles of a solid have fixed positions, only slightly vibrate about their mean positions, while the particles of a gas are very far apart and they can move anywhere in space. You can see that. The kinetic energy of the particles of a solid is very less because the speed of movement of particles of a solid is very less. It's slightly higher in liquids, and of course the particles of a gas move very fast. The force of attraction is very less in solids. It's slightly higher in liquids, and in gases the particles just move far apart from each other, and there's hardly any force of attraction, as I mentioned before. Now it is because of this structure of solids, liquids and gases that we get those different properties of solids, liquids and gases. So let's keep this structure of solids, liquids and gases in mind, and now let us try to analyze the properties of solids, liquids and gases that we just studied some time ago. You see, solids have a fixed shape and a fixed volume. Now that is obvious, isn't it? After all, the particles of a solid have fixed positions. They only vibrate very slowly about their mean positions. That is the reason that solids have a fixed shape and volume. Also, the forces of attraction between the particles of a solid, they are very strong, so they fix the shape of the solids, and that is why the volume of solids is constant. Now liquid particles are a bit freer than solid particles, and that is the reason the volume of liquids is fixed but the shape is not fixed, because the particles can move and change the shape of the liquid. Gas particles, of course, are extremely free to move. They can move anywhere they want. No wonder then that gases have no fixed shape and no fixed volume. Another property that we studied earlier was that solids cannot be compressed. Now this is obvious, isn't it? This is because solid particles are fixed. The forces of attraction between solids are strong. So you cannot bring the solid particles further closer to each other. What is compression? If you have to compress any substance, you have to bring its particles further closer to each other, isn't it? This can't happen in solids because solid particles are already very close to each other. Liquids also cannot be compressed because the particles of a liquid, though they are slightly far apart compared to solids, they are also very close to each other. So they also cannot be compressed very easily because the particles are already quite close together. In case of gases, however, there can be compression. This is because the gas particles are so far apart from each other that they can easily be brought closer and closer and closer. Here you can see that gas particles can be compressed quite easily, isn't it? This is how gases can be compressed. In fact, we use compressed gas in our kitchen. The liquefied petroleum gas, LPG, that we use in our kitchens is compressed gas, isn't it? A large mass of gas is compressed in the small cylinder that we use in our kitchens. Another property of solids, liquids and gases that we studied earlier was that solids have very high densities. Again, that is obvious. You see, in case of solids, a large amount of particles are packed in only a very small amount of volume because the particles are close together. So clearly, the number of particles per unit volume is very high, and so the mass per unit volume is very high. In case of liquids, the particles are very close together but not as close together as in solids. So in this case, the density is less than that of solids because there are less particles in a unit volume of a liquid, isn't it? And so there is less mass in a unit volume of liquid. In case of gases, the densities are extremely low because the particles are so far apart that in a unit volume of a gas, there are very less particles, and so there is very less mass in 1 unit volume of a gas. That is why gases have very low densities. Another property of solids, liquids and gases that we studied was that solids do not, fill up an entire container when a solid is placed in a container. Liquids also do not fill up a container, but gases expand and fill up the container in which they are kept. Now this is also obvious because you see, the solid particles are really close to each other and they are fixed and they have very high attractive forces between them. So when you place a solid in a container, the particles are not free, to move about and fill up the container. So clearly, solids stay where they are even when they are placed in a container. In case of liquids, however, the liquid particles are relatively free to move. So they do slip over one another and they do take up the shape of the container. However, despite taking up the shape of the container, they don't fill up the container completely. They take up the shape of the container because they are slightly free to move, but they are not so free to move that they can just expand and fill up the entire container. Gases, on the other hand, they just take up the entire space available to them. As you can see, the gas particles are very free to move, which is why they expand and take up the entire volume available to them. Another property of solids, liquids and gases is the property to flow or the property to not flow. Solids do not flow. This is because their particles cannot slip over one another. What is flowing? Flowing means that the particles of the same substance slip over other particles of the same substance. This does not happen in solids because the particles can hardly move. They just vibrate about their mean positions. So the particles of solids do not flow. The particles of a liquid can flow because, as you can see, some particles of the liquid can slip over other particles of the liquid like this. And therefore, flowing does occur in liquids and gases because the particles can slip over one another. So, no flowing for solids, and yes, flowing does occur for liquids and gases. So, those were the properties of solids, liquids and gases explained. Now we know exactly why solids have a fixed shape, why they can't be compressed, why gases can be compressed, why gases and liquids can flow. We know the exact reason of why this is happening now. There you go. Let us now move on to another concept which is very relevant in this chapter, the concept of diffusion in solids, liquids and gases. Do you remember the concept of diffusion that we had studied in the previous chapter? We had said that matter particles in general move from their region of higher concentration to their region of lower concentration. Perfume particles, for example, move from the area near the perfume to a place far away from the perfume, which hardly has any perfume particles. So, which particles diffuse faster? Does diffusion occur in solids, liquids and gases, all three? In which substance is diffusion faster? Clearly, diffusion is faster in gases compared to liquids. Diffusion in liquids is much faster compared to diffusion in solids. This is obvious, isn't it? You see, the particles in gases have a lot of freedom. There's a lot of space between the particles in gases. Therefore, the particles can easily diffuse from their region of higher concentration to their region of lower concentration. In liquids, there is some freedom of movement and there is some space between the particles. So diffusion does occur. But particles don't diffuse so easily, from their region of higher concentration to their region of lower concentration, because there is some restriction also in liquids. In solids, there is hardly any diffusion. This is because there's hardly any freedom of movement. The solid particles, they just vibrate about their mean positions, and that too very, very slowly. So they're not really free to move into some other solid or diffuse from their region of higher concentration to their region of lower concentration. So you must have observed that perfume particles diffuse from the perfume to, say, fill up the entire room. However, if you take a glass which is placed on your table, that glass will not diffuse to fill up the entire room, because as we just saw, solid particles hardly diffuse. Here we can consider those examples that I mentioned. Perfume bottle here has its particles diffusing all through and filling up the room. As you can see, very fast diffusion occurs in gases. On the other hand, when you drop an ink drop in water, the ink drop does diffuse into the water, and it does color the water green if the ink is green in color, but this diffusion occurs very slowly. You can see that in around 1 hour the water becomes slightly greenish, and it takes approximately 1 day for the entire ink to diffuse completely inside the water. The point is that while those perfume particles spread almost immediately throughout the room, that ink drop took 1 day to diffuse uniformly in water. So clearly diffusion in liquids is slower than diffusion in gases. Diffusion in solids, as I just said, hardly occurs. Let's take a gold block and a silver block and let's tie them together. Now let's keep these two blocks tied for a long time. How long? Well, let's keep these blocks tied for months and months and months. And then let the years pass. Let's keep these two blocks tied like this for 5 years. It has been observed that when you put gold and silver blocks close to each other for 5 years and tie them like this, then when you remove the knot after 5 years, some gold particles are found in the silver block and some silver particles are found in the gold block. As you can see, diffusion has occurred in solids, but it is so very slow. In this picture, you can see that only a small amount of silver is visible on the gold side and a small amount of gold is visible on the silver side. So diffusion is very slow in solids. So there you go. Diffusion is fastest in gases, it's slightly slower in liquids, and it is extremely slow in solids. Now that we've learned so much, shall we solve a problem? Let's. Bromine gas diffuses into air in about 15 minutes. How much time will it take to diffuse in vacuum? The same time? More than 15 minutes? Less than 15 minutes? We cannot predict this with the information given. Which option is correct here? Can you think of the right answer? Well, you see, when you allow bromine gas to diffuse in air, these brown particles of bromine gas move, they collide with the air particles, and slowly, the concentration of air particles and bromine particles becomes the same everywhere throughout the container. However, the diffusion of bromine in air is slower because of collisions with air particles. You see, the bromine particles collide with the air particles and sometimes they change their direction, so it takes more time for bromine gas to fill up the entire container. However, when you diffuse bromine gas in vacuum, as you can see, the diffusion occurs almost immediately because there are no particles to collide with and there are no particles of air stopping the bromine particles from diffusing. And therefore, the diffusion of bromine in vacuum is faster because there are no collisions with air particles. That's our final answer. As you can see, option C is our final answer. Bromine will take less than 15 minutes to diffuse in vacuum. Let's solve another problem. Which of the following statements is not true? The particles of a solid vibrate about a fixed position. The particles of a liquid are arranged in a regular pattern. The particles of a gas exert very less force on each other. The particles of a gas occupy all the space available in the container. So can you make out which of these statements is wrong and which of these is correct? Well, the first option is clearly correct. The particles of a solid do vibrate about a fixed position. They can hardly move. The second statement, however, is wrong. The particles of a liquid are arranged in a regular pattern. Not at all. In fact, they are free to move. Of course, they are held together in such a manner that the liquid does have a fixed volume, but then they are definitely not arranged in any regular pattern. The liquid particles can even slip over each other. So option B is definitely not true. The particles of a gas exert very less force on each other. This is true because the particles of a gas are very free to move and they move, here, there and everywhere and fill up the container. The particles of a gas occupy all the space available in the container. This is again true because as we just learned, the particles of a gas are so free to move that they move, they fill up the entire space available in the container. And therefore, only option B is correct. That is, option B is not true. So that brings us to the end of this chapter related to the states of matter. Wasn't the study of the properties of solids, liquids and gases, and why solids, liquids and gases have these properties? Wasn't all of this interesting? Let's now move on to the next chapter.